All right, welcome back everybody. Hope you had a good break. We're going to be starting with the next session. We have Catherine Olschanowsky from Colorado State University, and she's talking about BGPmon.
Thank you. So I'm Kathy Olschanowsky, and I work in the Network Security Group at Colorado State University. The main project that I'm working on right now is the RouteViews plus BGPmon project. And so when I refer to RouteViews plus BGPmon, I'm talking about the coming together of the two different projects to offer the data in new formats and with a live stream, and to make it easier to access that data. Now, I think a large percentage of the people in this room are very familiar with RouteViews and BGPmon, but bear with me for just 2 minutes while I give a bit of a history lesson for newcomers or people who maybe haven't interacted with the infrastructure. RouteViews, closer. RouteViews started out as a grassroots effort. It came out of the operations community. And this is because the operators recognized the value and the need to see each other's routing data. From that effort, researchers, university researchers in the government and security recognized the value of this data and adopted its use. And from that point, it became a funded project. It's been funded through the National Science Foundation, through the DHS, and through Australia's CERT. So, how do RouteViews and BGPmon play together? Okay, this is a quick overview of how the data is collected in a very abstract manner. RouteViews peers directly and speaks BGP with a large set of peers, approximately 200 peers at this point. From that point, the data is changed into an MRT format. MRT is essentially a binary format that wraps the BGP and gives you some header information so that it's easier to work with. RouteViews then archives all of that data. We collaborated with RouteViews so that at the same time that they're archiving their data, they go ahead and they forward that MRT stream to a BGPmon collector. The BGPmon collector consumes the MRT and transfers it into XML. We then archive the XML, as well as transform the XML into a textual format based on the output that you would get from a BGP dump-m run. And we also make the XML available through a live stream. Now, BGPmon can receive more than just MRT data as their input. BGPmon is capable of doing direct peering, so we speak BGP. It would be more accurate to say that we establish a connection and then we listen BGP, because we will not send any updates. We can also receive XML from another BGPmon instance. This allows us to build a mesh of BGPmon instances. And that is helpful because there's a single point of access for all of the XML data. And as a user, you don't have to be aware of where that data is actually coming from, or the fact that there's 30 instances of BGPmon providing that data to you. None of this would be possible without the people and the organizations who are willing to work with us to provide us data. So this is only a small subset of the organizations that provide data to us. But we wanted to say thank you to all of them, as well as ask for more data. So if anyone is willing to establish peering relationship between RouteViews and their exchange point, we would be very happy to speak to you about that. The person to contact for that would either be me or John Kemp. In all reality, I will forward you to John Kemp. Unfortunately, the weather on the West Coast is making it difficult for travel right now, so he's not at this meeting. However, either one of us can help get that set up. So when I talk about the RouteViews plus BGPmon effort, we really are two separate efforts. The first is an infrastructure effort to provide the data stream. The second is a set of software. We publicly provide not only the BGPmon core software, but a set of Perl modules that sit on top of that as well. I'm going to start today by talking about our deployment. So at this point, we have collectors spread around the world. We have over 200 peers set up, and all of that data is available in archived format, as well as a large majority of it is available through the live stream at this point. And as I mentioned before, there's 3 different formats that you can get the data in: the binary MRT, XML, as well as the textual format. The reason for doing this is because we want to make the access to the data as easy as possible, so that if you have a really cool idea and you want to try to write a client that processes the data, that there's almost no entry cost or learning curve to doing that. Here is a geographical view of where we collect our data, and you can see that we're starting to deploy the mesh of BGPmon instances as well. And those 3 rectangles actually represent a larger group of collectors. We have paired one BGPmon with each of the RouteViews collector instances. The reason for the one-to-one pairing is that we maintain an internal rib table for each of the peers. And so we found that this helps us with our scaling. You can see that the data is ingested as a BGP. The red lines represent the MRT, and then once they leave the first entry point into the BGPmon network or mesh, then we're speaking XML. The XML is what we refer to as chained. It's chained through the next XML, the next BGPmon instance. And what this means is that we do a minimal processing, and we essentially are just passing the messages through. And that is what enables us to provide all of the data through a single interface. In this particular configuration, the public interface is BGP data test. The reason it's BGP data test is because we've recently had a lot of movement and a big upgrade in our system, and I'll talk about that a little bit more later. So what I'd like to do now is give you some examples of how this data can be used. So I have 3 demos, well, 2 demos and 1 overview explanation of how we are collaborating with different groups to process the data. All of these demos are supported using our Perl modules. And what I'd really like to communicate today is that we would like people to try the Perl modules. Tell us what's cool about them, tell us what's not so cool and needs to be changed. We'd like to make it as easy as possible for everyone else to go out and write these clients. So this first example, we wrote in cooperation with a group from ISI. It's supported by the Retro Futures project. What we're attempting to do in this demo is to provide a view of the whole IPv4 space from a single vantage point, and to communicate as much information as possible in one shot of what's going on. So we chose an interesting time frame to display, and we're using a Hilbert graph to display the data. We took all of the BGP data that we had available for the Australian outage that happened in 2012. This is about 45 minutes of data. And we chose one interesting peer from that data and put together a visualization of the Hilbert graph. So again, this was in collaboration with a group at ISI. We have 45 minutes of data. The movie is 3 minutes long, so it's compressed down to go much faster. This is a quick overview of what a Hilbert graph is, and you can come back and refer to that if need be. So this is our Hilbert graph as the event is happening. Every time one of those squares lights up in white, it means that we have received a path change for that prefix. Now, during typical traffic times, Each peer is going to vary slightly, but you only see a small amount of white speckling. At the beginning of this event, you can see that there's large areas of the prefix space being updated all at the same time. What happened during this outage is that one of the ISPs, a smaller ISP, accidentally announced a bunch of routes, and all of a larger ISP's traffic was routed through it, causing the internet to go down. Now, what this view is showing you is, because we have the color map at the bottom that can show you the geographical information for that prefix blocks, you can see that it's mostly prefixes in North America that are being updated with this bad path information. The other thing that it's showing you is that there wasn't a single burst and then kind of a tabletop graph where that bad path was existed for the entire outage, and then a fix at the end with another burst. That there are many different bursts during the outage, and that the prefix of that ISP actually comes and goes throughout the entire outage. And so this is the last burst, I believe, where everything's being updated. And you can see that the majority of the points are coming from our prefixes in North America, but there's also a significant amount of activity in Africa. So this gives you a lot of information all at once. It's great for human consumption and for you to understand the event. However, it's only from a single vantage point. So we're only seeing what's happening from a single peer. And it may be more useful for us to see perhaps a little bit less information about each individual peer's traffic, but get to see a wide range of peers all at the same time. So the next demo that I'm going to show you, I'm going to let this wrap up here. The next demo that I'm going to show you attempts to do just that. We're going to look at higher level statistics. They're cheaper to calculate, and they're easier to display, so we can see a wide range of vantage points all at the same time. This software was developed by one of the students in the NetSec lab, by Lawrence, and he used our Pearls tools to do this. He was able to put this demo together in only a few days because the Perl modules do the vast majority of the work for you. And it's a tabular view of the same data. So what we're going to see now is that anytime one of these statistics from one of these peers jumps out of what we consider a normal range, you get either a yellow alert or a red alert that lets you know that something is going on that peer that maybe a person needs to look into. It's interesting because while it's not difficult to calculate these statistics, it is a little bit more difficult to know where to draw the line. So what statistics do we need to be monitoring? And at what level do we decide that we need to send out an alert? I'm sure that you don't want to be getting paged every 5 minutes because a peer is experiencing some bursty traffic. So what we've done here is just chosen some very simple high-level metrics, and all of the alerts that you saw in that example came from path changes, and that's due to the nature of the event that we were monitoring. Additionally, all of this data was taken from our archives. Now, all of the software that we've written that can read from the archives also has the ability to read from the live stream. So it's possible to set up this type of a client and have it running against the live stream and get the alerts in almost real time. There is a bit of a delay. So both of those use cases were monitoring specifically kind of wide area, the whole view of the internet from a specific peer. But if you're an organization like a bank or a government or a business, you may want to focus your attention to a smaller space, specifically the prefixes that you directly depend on. So this is a project that we put together with the team over at Australia CERT, where we were monitoring a specific list of prefixes that they deemed critical. We wrote a user interface and software that helps them determine what does it mean for a prefix space to be critical and how to maintain that list, because that list will be changing. As well as we wrote a series of clients that take the live data, filter it down so that we're viewing just the prefixes that they're interested in. And then we store the data in what we're calling a longitudinal database that keeps track of the changes in those prefixes from each vantage point that's available to us over a long period of time. This enables us to collect historic analytics on those prefixes and identify when something like an origin change happens, which would be suspect for the organization to not know about ahead of time, and if any odd path changes take place. This is just a quick overview of the software that we developed for this effort. We take the box on the side there shows you the database that we developed, a database to hold the prefix list for us and allow it to be updated. That list is exported to a client that's listening to the live stream. And all of the software that's indicated in those boxes is freely available on CPAN. And so the prefix data can be parsed and filtered. It is entered into a database. The database schema and code to set that up is also freely available. And then we have some analytics that are running on the database. And that's where our current research is in trying to figure out which analytics are interesting and what do we want to know about these prefixes and when should a person be brought into the loop for looking into what might be a possible attack. So I've been talking about the Perl modules, and this is the main takeaway that I'd like everyone to have from this talk, is that we've made it very easy to access this data. This is just a subset of the Perl modules that we've made available. In our core package, we have code that allows you to fetch data from the live stream or from the archives. It fetches the data for you, parses the data one message at a time. You then have a choice. You can either translate that data into a Perl hash or an object, or you can examine the data directly as XML using your favorite XML parser. And we also provide basic modules that help with configuration and logging so that all of the BGPmon tools have a common interface and behave in a similar manner. We use and make available the BGPmon archiver package. And so this is not only a set of modules that help you archive the messages, but also a script that can be installed on the system. And what this enables you to do is if you run your own BGPmon instance and choose to archive it, it will make sure that all of your archives are using the same formats as ours, so that if someone decided they wanted to share, they wanted to grab data not only from our archives, but yours as well, for them it would be seamless because the data is laid out in the same format. And so our fetching modules would be able to get through that data without the programmer needing to know that there was any difference. We also make the analytics database available. This is a relational database right now. It's in Postgres, as well as the CPM module. And there are several other modules that are in the works right now. We're about to release one that gives you the ability to choose any point in time and get a dump of a specific peer's rib table at that point in time. And as I said, all of these are freely available on CPAN. So here's just a very quick example of what it's like to code using the modules. In this example, we're just going to count the number of path changes for a specific pair. So I believe that this is code that is pulled from the second demo that I showed you. And the important pieces here, once you pull in your modules that you want to use, you essentially just need to call connect BGP data and provide it with the URL and the port, the host name and the port that you would like to connect to. In this case, it's grabbing it from the live data. And as long as you are connected, you read the next XML message. So you get the XML message one at a time. At that point, you have several choices. You can validate the XML message. You can filter the XML message. In this case, it's just being parsed. And once the XML parser does its job, then you can start calling extract to extract the different pieces of the messages. And so in this case, we're extracting the AS path so that we can compare and see if it's changed, and we're extracting the NLRI section so that we can get the prefixes that are affected. And then we do our analytics. So just a little bit of math. All of the modules are designed in a similar manner so that they're nice and easy to use. So I've alluded a little bit that there's been a lot of changes happening inside of BGPmon recently. We are currently on our 7.3.3 release. The major goals of this release are increased stability, as well as we've made a huge change to our XSD. Okay, so the XSD is used to validate all of our XML messages. It's also used internally to parse the messages and create data structures. And so in Perl, as well as in other languages like Java and Python, you can actually use the XSD to create your objects in your code so that you don't have to even write the code. The new XSD is more robust than the previous XSD, and it allows us to expand the information that we're providing. So one of the very important things that we're doing at this point in the XSD is that we have a metadata section, and we have the ability to annotate the data without touching the original data. Additionally, we plan to add a section for data provenance so that you know the path that the data took through the system, and you can decide if that data is trustworthy or not. So the high-level takeaway points that I really want to get through for this talk and this audience is that we can always use more peers. We would like to expand the system and have more data available. And there's a huge effort underway right now to make this data easy to use. We've started out with Perl modules, but we're very open to moving into other languages as well. XML doesn't care what language is parsing it, and so we will provide what people communicate to us that they need. And so try out our tools and let us know how we can respond to what you need. I also like to say thank you to the rest of the team members who work hard to put this together. Thank you.
Are there any questions?
Hi, Jared Mach from NTT. So in the past, I've looked at, I've done some studies on the BGP updates that we see over time to look for transient routing leaks. Have you looked at integrating any of that type of capability in here in this system as well?
So the primary goal of this system is to actually provide the raw data, and we do as little manipulation of the data as possible. And it would be a client, a developed client, that would then perform any type of analytics or analysis on that data but that's exactly the kind of application that would be appropriate for developing a client.
Okay, yeah, because I've looked at using the BGPmon code in the past, and I had a number of operational issues trying to deploy it and configure it and stuff like that.
Absolutely. And that's why I said there's been so much activity over the last year. In the last year, we've really focused on solidifying not only the core BGPmon software itself, but also the clients are fairly new. And so one of the reasons that we've done the demos is so that we eat our own dog food, so that we have to be using those client tools, we discover what's wrong with them, and then we can fix them. And so if you look up on CPAN, you'll see a lot of updates have been going through. And we're getting to a point now where they're much easier to use and much more stable.
Okay, I'll have to take a look at it again. Thank you.
Okay.
Anyone else?
Okay, thank you for your attention.